1.2 homework. Number 11, find the length DB. So there's a variety of ways I could divide up line segment DB, DC and CB, a few others. I'm going to use 0, because 0 is very easy to calculate from. I know that the distance between D and 0 is 5 1/4, and the distance between 0 and B is just 2/3. I'm looking for how can I make these have the same denominator. It turns out if I multiply them by each other, I get 5 3/12 plus 8/12, which is 5 11/12, the distance between D and B. For 15, the key idea is that this blue part plus this red part equals the entire green line. Everything is measured in terms of variables, so I have to set up my equation like so. I can combine like terms, which gives me 3.5x on the left, and from here it's solving for x. So maybe I'll subtract 5x from both sides. Negative 1.5x is equal to negative 3. If I divide both sides by negative 1.5, I get x is equal to 2, which is not my final answer, because I have to plug this in to 2.5x. So 2.5 times 2 is equal to mn. mn is equal to 5. 17, like most of these problems, becomes clearer when you draw it out. These red lines indicate that E is the midpoint of DF. The two distances are equivalent. What that means is that 2x plus 4 is equal to 3x minus 1. I can subtract 2x from both sides. I can add 1 to both sides. I get that x is equal to 5. I'm going to take this value and plug it in for, say, DE, since DE is equal to 2x plus 4, so I can substitute 2 times 5 plus 4, and DE is equal to 14. I could do the same plugging them into the others, but if this is 14, then so is this, and the two put together are 28. Number 19. How is C related to AE? These markers indicate the distances are equal, which means that C is the midpoint. C is the midpoint of AE. 19b. They tell us that AC is equal to 7 feet, that EF is equal to double that length, so 2 times 7, plus 2, which is equal to 16, and that AB is equal to 2 times EF, which is 2 times 16 minus 16. And this is equal to 16. So both AB is equal to 16 and EF is equal to 16. 21, we are told that CD is congruent to DF. So this length is the same as that length. We also know that E bisects DF, so it cuts it into two equal parts. If CD measures 14.2, these have to be 7.1 each, because it cuts that length in half. EF is equal to 7.1. 23. GH bisects CF, meaning that CD and DF are equivalent. D is the midpoint. We know all of CF is equal to 2y minus 2, and since CD is 3y minus 11, that means that DF also has to be 3y minus 11, because they are the same, since D is the midpoint. So we can take 2 and multiply it by 3y minus 11. That'll give us the total length. If I distribute, take 2 and multiply it by each term inside of the parentheses, I end up with 6y minus 22 is equal to 2y minus 2. I'm going to subtract 2y from both sides. 4y minus 22 is equal to negative 2. Add 22. 4y is equal to 20. Divide by 4. Y is equal to 5. If I plug that back in, I know that CD is equal to 3y minus 11. So I can replace y with 5, and 3 times 5 is 15, minus 11 is equal to 4. That's the value of CD. For 25, if M is between A and B, then M bisects segment AB is sometimes true. In this example on the left, M is the midpoint, and it does bisect segment AB. But in this example, a counterexample, M is not the midpoint, so it does not bisect AB. For 27, remember that lengths are equivalent. Length AM is equal to length MB, and that segments are congruent. So segment AM is congruent to segment MB. Letter A is wrong because we're missing the bars on top of those letters to indicate we're referring to segments instead of lengths. 29. The coordinate of M is 2.5, so let's plot it on a number line. If MN is 4, there's two possibilities. N could be sitting over here at 6.5. That would give us a distance of 4. N could also be sitting over here at negative 1.5. That would also give us a distance of 4. So we should write negative 1.5. So for this next section, 31 and 33, we have a segment RT, and S is somewhere between the two. So we can add RS plus ST to get the total RT. For 31, we set the problem up like this. We combine like terms, which means our Y terms are added together. We can combine our number terms, and 5 minus 4 is 1. When we subtract 1 from both sides, 8y is equal to 27. Divide by 8. And this becomes 3 3/8, as 8 goes evenly into 27 3 times with 3 remaining. The same setup for 33. RS plus ST is equal to RT. I can combine my z terms on the left, combine my numbers, subtract 5z from both sides to keep this positive. Z plus 3 is equal to 12. Subtract 3 from both sides. Z is equal to 9. 36 requires a bit of setup. If you follow all the orders of what goes between what, you get a segment like so. We know that the entire distance, PT, is equal to 34. They tell us that QR is equal to 8. And we know that PQ is equal to SQ, which is equal to SR. So PQ, SQ, and SR are all the same. And if QS and SR are the same, then S is the midpoint of QR, which means these are both 4. Which means this one is 4. So I can carry these down and say 4 plus 4 plus 4 plus what is equal to 34. And that tells me the length of RT. So 12 plus RT is equal to 34. Subtract 12 from both sides. RT is equal to 22. Oh, it's multiple choice, right? Since C is the midpoint of AD, and B is the midpoint of AC, it's almost like this is divided into 1/4, 1/4, 1/2. And since we know that BC is equal to 12, we can multiply that by 4 and get the answer J, 48. For 38, for congruent, we can rule out C and D because they have just equal signs, and we can rule out A because it's missing the segment bars on top of X, Y, and VW. That leaves B. 39 suggests that A, B, C, D, and E are collinear points, all in the same line. The distance of the entire segment, AE, is 34. And then we have some equivalencies. AB, BC, and CD are all equal. And we know that BD is equal to 16. Well, BD is comprised of BC plus CD. So that means that all of these are 8, 8, and 8. And they wanted the length of CE. So we have 8 plus 8 plus 8 plus DE is equal to 34. If I combine like terms, we can figure out quickly that DE is equal to 10. And combining that with CD, which was 8, and I get a value of 18.